All right. I just kicked off the recording as well, so just FYI. And,
Thank you. I was about to, but if you're doing it, great. So this is July 16th, 2020 Cloud Provider Extraction Working Group meeting. This is part of the SIG Cloud Provider, which is part of CNCF. We have a policy of conduct to please be respectful and inclusive of all of your other contributors. So please be, inclusive and considerate of all your other contributors. Having said that, I'm going to go ahead and kick off the meeting. I know we have a few folks from the APIServer Network Proxy project. This is originally started as the SSH tunnel replacement, and there was some interest in extending the APIServer Network Proxy to be able to handle traffic to go from the cluster to the control plane. So with that introduction, would either Sri or Locopo care to kick in and let us know what you're thinking?
Yeah. Hi all. Here, Jacopo speaking. So actually, as Walter said, I quite recently discovered this APIServer proxy, and I tried to use it in a project I'm working on, where basically we have the control plane of some Kubernetes clusters that is running in a dedicated Kubernetes cluster that and the cluster network, so the worker nodes are normally running in a distinct network. Currently, we are using OpenVPN in order to do basically the job of the APIServer proxy, but it would be interesting for us to replace this and use the APIServer proxy instead. But this would solve only part of our issue, because we would be also interested in using the APIServer proxy basically for the cluster to control plane communication. And I saw there was already an issue open. There was some discussion around this. So probably there are some complications to put this in place. But I took a look to the code base, and I think the tunnel already, I mean, there is not much difficulty in using the tunnel on both directions. Probably the tricky part is the bootstrap, because the components that are running on the cluster network need to communicate with the APIServer during the bootstrap phase. So probably, I mean, for the instead of using a demo set, a static pod should be used, and for the authentication, probably we should rely on mutual TLS, but the certificates should be distributed with some offline mechanism, I think. And probably there are also other complications. Basically, this is why I'm here. So I would like to get your opinions about this topic, and yeah, I'm also available to contribute to this if there is interest in this topic.
So while people are considering that, and please feel free to chime in any thoughts, opinions, etc. A few things that I think are worth mentioning. Justin Santa Barbara, specifically Justin when he's working on the AWS side, I know was considering doing something very similar. So I definitely would make sure that you loop in Justin SB. And in fact, I invited him to show up to this meeting, warning him this subject would be here, but I don't see him on the call. But that's one quick note. You already mentioned the interesting part of today we generally start these up, the agents up as daemon sets, but we've got at least two other options. The one you mentioned, which is to make it a static pod. You could also have it as a service on that VM, etc. I know a lot of folks do the service solution for things like NPD on kubelets. So I'll just mention that that's possible. When we're routing traffic in the other direction, and I'm not sure what your solution in mind is, but I'll mention the Kube API server is the only thing that currently talks from the control plane down to the cluster. And it has some code specifically to look to direct traffic through the tunnel. I don't know what it is you have planning on going from the cluster up to the control plane, but obviously you need to solve the problem of getting the traffic that you want to send to the control plane into the tunnel to begin with. So I am not a networking expert, but I'll just mention I'm fairly sure that we need to work out how you plan on doing that. And while the tunnel segment from the server, or from the client to the server, which is to say from the Kube API server to the connectivity server, has currently been set up to handle multiple different protocols. So it'll do MTLS HTTP Connect, MTLS gRPC, or gRPC UDS. The only thing we've actually built into the segment going between the agent and then the connectivity server is gRPC over HTTPS, although you do have, I think, some options on how you want to do authentication. So I believe that segment can be authenticated either via MTLS or via a authorization request to the Kube API server. So I think, you know, if you wanted to do that via something like OpenVPN or something else, there's clearly some work there that would need to be done. We had someone, and I don't remember who, asking about this specifically a couple of days ago on the APIServer Network Proxy, and I will say in this meeting the same thing I put in the issue, which is that I am wholly in support of that work. We just need someone motivated to actually sit down and do it. But any one of the leads of the project, I think, would be happy to provide some advice and some review cycles to make that happen.
Yeah, cool. So Walter, I just wanted to add a few things to it. So just to give a quick introduction, I'm Balaji. I'm working as a senior developer in Amazon EKS. So in EKS, what we do is we have two set of networks, and we run all our master components on one network, and then the customer's workload runs on the other network. And then, so we do the way we set up the connectivity is whenever we bring up on master, or when a customer upgrades their cluster, say from 115 to 116, then we attach a cross account interface that gives access from that master to the worker node. So what we are trying to avoid is, instead of creating this cross account interface for every master, have a separate VM that will have one cross-account interface, which will run the proxy server. And then the API server will connect to this proxy server. And then we don't have to like set up this network for every master instance. So that's what we were trying to do. And having the connectivity from the cluster to control plane through this API server proxy will help us there as well, so that we don't have to like set up the network for every master instances that comes up.
Yeah, that sounds familiar and sounds eminently sensible.
Yeah.
A couple of quick thoughts, and I don't want to tell you how to do your thing. But just a quick thought is you may want to run 2 copies of connectivity server in the sort of setup you're talking about, just because HA concerns are a real thing, and you don't really want to have it go down and suddenly you lose all communication. On that note, and this is where I think I'd have to defer to Chow, because I believe Chow wrote the relevant code, but the agent has a way of knowing how many connectivity servers it wants to talk to.
Right. Yes,
Um,
I was looking at it. It looks like the server returns the server count to the
Yeah.
agent. And then depending on that, agent decides if he has to connect on the other server or not.
Exactly. And so I don't know how easy it is to have a connectivity server count that is different than the Cube API server count. So I'm hoping maybe Chow can chime in.
Yeah.
You can, I mean, that's a flag in the connectivity server, so you can set it to whatever number you want.
Okay, so if you wanted to, it's pretty easy to set up too. Okay, awesome. But yeah, that makes perfect sense, Sri. I think we do it a slightly differently, but we do something very similar. So yeah, it makes sense to me.
Yeah. Okay. So Walter, what do you think the next steps are? Like, how do we start? Or
So personally, I would start with the design proposal, right? And you may want to have 2 copies if you need some of it to be internal and then just sort of an external. But I think, as far as some of the deployment stuff goes, that's on you to solve. So deploying the agent, other than, as Damon said, I don't think that's something we need to worry about.
right.
It's really about tunneling the traffic, right? So you need to understand how you want to authorize. You need to understand how you want to tunnel traffic. The other thing I would think that's worth mentioning is when the traffic comes out of the connectivity server, where is it allowed to go? So if you want to do the nice simple thing, I would basically just have a way to configure on the connectivity server some restriction that is this equivalent to only send traffic to the Cube API server. Maybe even only send traffic to the Cube API. Yeah, I mean, I don't know how to put it, but I assume you probably don't want to let things in the cluster do things like talk to your etcd server or equivalent if you have some etcd lookalike. So I would be a little careful about what happens, especially since you probably put a firewall and a hole in the firewall to get to the connectivity server. If the connectivity server then can fan out to anything in the control plane, you're kind of opening yourself up to attack. So we need to, one, think how we're going to control that. And then how we get traffic in, how we get traffic out, and whether, I mean, if you want to use gRPC from the agent to the client, then we probably just need to extend the handshake code a little bit to allow connections to happen in the other direction. I don't know if you want to alternately switch to something like VPN, in which case there's some code there that needs to be written. That's what comes to my mind. Chow, did you have any other thoughts?
No, not really.
All right.
So with respect to authentication, like we do have something called as an IAM authenticator that we run on the worker node.
Mm-hmm.
So that when you talk to API server calls another webhook that runs for the
Yep.
authentication, and then that returns either this guy is authenticated and then what are all the set of groups that this particular user belongs to. So in this case, let's say we go ahead with this, and then if an agent has to if an agent receives the packet from any of the kubelet or the pod and then sends it all the way to the API server, then for this authentication, then there has to be some more work that needs to be done, right? Or is the work already there?
So there's multiple levels of authentication here. So I'm going to work my way at the bottom and work up. So the first one is authenticating the tunnel. So when the agent talks to the talks to the connectivity server, it has to be able to authenticate itself. So that's one level.
Yeah.
MTLS is a fine way of doing that. If you want to do anything, one of the other option that we have right now is to be able to get authentication materials from the Kube API server and use those.
Mm-hmm.
The problem with that solution in the space you're talking about is that we need that tunnel working before we can even talk to the Kube API server to get our authentication materials. So that second option isn't going to work in this scenario. After that, you then have the issue of when the customer, for lack of a better term, when the customer sends a packet to the agent, you have the option of forcing them to authenticate, which probably means the customer, whether it's kubelet or whatever, has to have a special library, or you could set up a routing rule that just sends the traffic and there's no authentication needed between the customer and the agent. Let's go with that for now, and correct me if that's an invalid assumption, but I'm assuming you don't really want to run custom code in the kubelet. So the agent's just going to hand the traffic up to the connectivity server, and so now the connectivity server has to do something with that. So I think you probably want to have some sort of rule about where traffic can be dropped on the network, possibly something that says, I have a list of known good Kube API servers, or I have an address of a load balancer across the Kube API servers, and the traffic has to go there.
Mm-hmm.
I don't know enough about your infrastructure to know exactly how to do that, but I'm assuming you're going to want some sort of restriction. It may even just be a port restriction, but something to ensure that the traffic only goes to the Kube API server. Once the packet hits the Kube API server, I think you're okay, because kubelet already has authentication materials for talking to the Kube API server. So it's going to have some sort of service account and a service account token, or an MTLS, or however you set it up. But Kubernetes should already have authentication of anything that's talking to the Kube API server. So I don't think you need to worry about that particular problem. I think that's already been solved for you. That was kind of a long-winded answer, but did that make sense, Ray?
Yeah, that makes sense, Walter. Thank you. Yeah, that's what I was thinking about. Like, if I have to do something at the API server to see who's the originator of the packet is and authenticate them.
So generally we do that by service account, and so I think you're going to be just fine.
Okay. Cool.
Yeah, maybe I can give my 2 cents around this, because
Please.
I did a small POC even before discovering this APIServer proxy, but basically I was using a similar solution, basically to route the traffic from the cluster network to the API server. Basically, I was using Envoy in order to tunnel the traffic using HTTP2 connect. It's a feature that has been recently introduced in Envoy. So basically, I used a tunneler that is running on each worker node, that is basically equivalent to the agent. And then there is another envoy on the control plane network. It is basically the tunneling and sending the request to the API server. This with this solution, envoy allows also to restrict the possible destinations, as Walter mentioned, to avoid to have too much opening. I mean, you cannot send to whatever destination. And in order to intercept the traffic and send it to the tunneler, that would be equivalent to the agent, I tried several solutions. One is based on IP tables. I also tried with using IPVS, similarly to what is done by the Cube proxy. And another solution was basically I'm creating a dummy interface, and the agent is binding to this dummy interface that I'm using. I'm associating a private IP to this dummy interface, and I'm using this IP as advertised IP in the API server, meaning that the endpoint associated to the Kubernetes service will use this IP. So the traffic will be sent directly to this interface and will be tunneled. I worked on this POC with Youssef, that is also present. So if he wants to add something, if I missed, but this is basically how we solved the.
Basically, just to make it clearer for this idea, and this was basically, we choose this solution because it seemed to be the easiest, and there wasn't any IP tables rules to implement and all the kind of overload, I would say. The idea is similar to Node Local DNS. I mean, it's the same idea. You run on the host network, you have a dummy interface, which you don't care if it's up and down, and you listen to this, you bind to this interface, and you receive all the traffic, as simply as that. And we wanted to use basically the same link local network of Node Local DNS, but this is one of the restrictions of on the default service of Kubernetes, where you can't use link local subnet, localhost subnet, and all the kind of restrictions. So we choose one of the three private IPs range. And while currently is working fine, to be honest. I mean, we are managing basically to send the traffic from all the worker nodes to different control planes behind one load balancer. Thanks to Envoy and the HTTP2 connect, basically we are able to route the traffic on basically, as we tunnel the traffic, we inject manually, or well, automatically, I would say, the name of the clusters, and then we load balance this to the right API server. So that's why we wanted basically to have this full connectivity server from both sides, because, well, from one side it sounds like really promising, and it would remove all this whole OpenVPN stuff that we put, and I mean, it's integrated directly to Kubernetes, so even better.
Yeah, sounds great to me. I mean, yeah, please, we're happy to advise, we're happy to provide you know, review cycles, whatever we can do to help make this happen. Now, the one piece, if I caught, it sounds like you would almost like to be able to have one connectivity service attached to multiple control planes.
No, actually, we have one agent per each node, but each agent is only communicating to one specific API server in our case.
Agreed. I'm sorry. Maybe I misunderstood what Youssef was saying, but it sounded like even though I want one agent talking to one Kube API server, it almost sounded like there might have been an idea of routing all the agents through one connectivity server and then having them correctly land on the appropriate Kube API server.
No,
Maybe I
exactly.
misunderstood that.
When I said the load balancing is done, well, basically on the load balancer side, AWS or whatever, I mean that the agent, the traffic from the agent to the connectivity server is, thanks to the HTTP2 connect, is sent to the right connectivity server. So even if you are behind just one public load balancer, we are able to bind connectivity, well, the agent with the correct server. So
yeah,
it's
basically we have multiple control planes on the same network, and we use a single load balancer to basically route all the traffic to the various API servers.
Okay, that's a lot easier. I was hoping that's what you were saying, but it almost sounded to me like you were saying you wanted the connectivity service to provide some of the load balancing. And I was like, okay, it's doable, but a lot harder. So that sounds a lot more reasonable. Okay, yeah, that sounds great. Chow, thoughts?
So apart from the authorization things you have been talking about, I think we also need to duplicate all the traffic forwarding and listeners, right? Because currently all those things are written for one direction, right? We need to open listeners for like on the agent. We need to listen for the dials from the kubelet.
Right.
And
but it's just the I think it's just the dials, right? I mean, once the dial has been handled, we end up with the same code because the traffic can go in either direction today, right? The only thing that's one directional is
we are saying we don't want to modify kubelet code, right? Kubelet will not be touched. Because
so the dial code has to get fixed because we need a list. You're right. I mean, we need a listener, but we have once the dial's done, we have a listener even today, right? The only thing we need to listen for that's new is the dial.
Yes, today the agent has a listener for the gRPC, right? That's all we have today.
Well, I'm saying like once you've established the connection, we have a stream listener, right? And so that's already, so once the stream's established, the existing code should work. Our problem is getting to the point where this being able to set up the stream in the other direction.
Yes, and to set up the stream, we also need to, because today we have our own protocol, right? We have the dial request, dial response. But if we don't change kubelet, how can we achieve this? I think we still need to, because we have already modified the API server. We have buried our client into, API server is importing our client. So it will send a dial request first, right?
Right. So I think the idea is that Youssef or Iacopo, please correct me if I'm misunderstanding what you're saying. But I think what they're saying is they add a listener on the agent. When it sees a connection packet come in, it is then going to generate a dial request and send it in the other direction. So we definitely need a new listener. We need it, but there's a new code path for doing dialing. And so then we send the dial up to the connectivity server. It drops the dial request, goes to the Kube API server. It sends the response. The connection response comes back down. We get the dial response. And at that point, the stream should be set up and we're good. I believe that's what we're saying.
Doable, yes. And the benefit is, what's the benefit of doing all this? Why do we need it in both directions? Is it, I mean, because in order for the agent to connect to the proxy server, we already need the network to be set up so that you can connect from the cluster to the master.
So if I understand the use case correctly, the use case is, let's say there are two connectivity servers running on their own machines in the control plane. They're running on their own machines. They're not running on the Kube API server machine. And so they can upgrade the Kube API server and put it on a new VM on a new IP address and continue the traffic, well, and continue talking to the connectivity server on the existing port. They may get a broken connection, but they can reestablish and keep going. And so they don't have to do any reconfiguring, changes of IP address, other things.
I see.
I mean, I think the other thing that is interesting about this is if you look at, and I mean, I don't think that's either Yusuf or Iacopo's use case. Excuse me, Iacopo, I don't know any name other than what I see.
It's Jacopo, but no problem.
Jacopo. But I know that the last one we had was, I think, someone who wanted to be able to run a control plane in one place and the cluster in another place and connect, basically like, you know, some sort of on-prem scenario, but with remote clusters and a centralized control plane. And they wanted to be able to connect everything using a VPN.
Mm.
And in that sort of scenario, it becomes even more clear that you may want to do this because it allows you to abstract away the problem of that remote communication.
Yeah, exactly. And just to give you an example, well, this is exactly what we have currently. We can have worker nodes on, I don't know, Google Cloud and the control plane on AWS. And we are still able to have the clusters up and running with completely separated brain and workers.
Yeah, I think the main advantages we see at the moment are first that it would give us the possibility to route the traffic to the targeted control plane passing from one single load balancer. That was one of our design goals. And on more long term, I think it could also allow us not to expose the API server directly to the internet. We should just expose the API server proxy, and we can have mutual authentication between the agent and the API server proxy. So it adds also another layer of security as we are talking about two distinct networks.
Sounds good. All right, awesome. Did anyone have anything else on this topic, or did we want to move forward? So thanks, guys. Definitely looking forward to seeing some PRs, maybe even a design doc. Happy to help collaborate. And just to reiterate, I think you probably want to reach out to Justin SB. So I think he knows quite a bit about this, and in fact also knows quite a bit about the Amazon use cases because, you know, he has been one of our Amazon SIG leads. Cool. If we're done with that, Nick, I think you had the next agenda item.
Yeah, it's basically just an update on credential provider extraction. So I'm coming back to this now. Didn't have cycles during the last release. So yeah, essentially where we stood when I was last working on it is I think we were relatively close, but there had been a decent amount of feedback that I had to add some tests to the PR, and then we need some examples of the binary that actually goes on the instances, so the cloud provider specific code for this. So we'll have an AWS example of that. We'll probably want to start getting other cloud providers working on it sooner in this release cycle. So yeah, my goal is to front load it this time, since here we are early in the release cycle. So the other sort of last time we were kind of deciding whether or not we wanted to in the alpha version start out with migrating into staging or not. And because the conversation had occurred a little bit late in the release cycle, we had decided to not do that. But I'm inclined to just get that up and running early this time. Yeah, all right, sweet. Yeah, so let's do that, and we'll have a better version of alpha given the extra time. So yeah, I'd say just watch the PR, and as soon as we have some progress on an AWS kind of example credential provider binary, we'll start getting some other cloud providers working on it as well. But personally, I just need to get back into it and kind of remind myself exactly where the work is right now.
Awesome. I was going to say, I know CC, who is on the call, has actually spent a considerable period of time trying to correct the mistake we made early on with not having CCM in staging, which I think has caused all of the cloud providers a fair amount of pain, and it's non-trivial fixing that now. So one, huge props for trying to get that happening earlier. I think that'll definitely be beneficial in the long run. A couple of quick questions. So obviously each of the cloud providers will be responsible for doing their own credential provider sidecar. What about the non-cloud provider use cases? So do you think there's any value in it for something like Kind, Bare Metal, or the fake cloud provider? Just talking to Docker.
Yeah. So you could structure it that way, where everything goes through the external credential provider, or you could sort of leave the existing Docker config credential provider as a sort of default baked in, separate from the external credential provider, similar to what we have today. I think both are viable. Right now, I have the default Docker credential provider just still baked in, not actually a separate thing. So yeah, if you think we should sort of break it out a little bit more, then feel free to comment on the PR, or
yeah, I'm
we can have a
torn.
chat.
I mean, I can see value in not doing it, but the one value I see in doing it is that it makes for a nice little reference implementation for anyone else who wants to see what they need to do without having to look through trying to distinguish what is cloud provider specific code from what is reference implementation.
Yeah, that's a good point. I'll revisit that and just kind of yeah, maybe we can have a conversation if it seems like it's feasible to do that, could be an easier reference implementation to build, and we could get that out faster, which would allow people to get their implementations going faster. So yeah.
That was my thought.
Why don't we look
I
into
don't
it?
know if it's viable, but awesome. Yeah, definitely. Thank you for considering it. Did anyone else have anything they wanted to ask on the credential provider extraction work? Steve, Jacopo, Youssef, Kendall?
Nope.
Cool. All right, I don't actually have the agenda in front of me. Did we have any other items that needed to be covered? Sounds like not. All right. Thank you, everyone. Great discussion today. And right now this meeting is every other week, alternates with the regular SIG Cloud Provider meeting. So, I think we're doing pretty well on time. And we'll upload the recording for this soon. If we discover that we have more stuff or we need to meet more often for the network proxy code than every other week, we can always have a separate meeting. But for now, I think this is working pretty well. Does that sound reasonable?
Sounds good.
All right. Awesome. Thank you, everyone.
Yes,
Thank
bye-bye.
you. Bye-bye.